Chemistry is often mentioned with a bad connotation. Most of the general public only hears about chemicals as a result of some tragic event, such as water pollution or oil spills. The gaining popularity of climate change associates chemistry with greenhouse gases, using science as a descriptive medium to describe complex chemical pollution on a global scale. Chemistry is far more than tragic events. Chemicals are as common as a clean glass of water or a breath of fresh air. Music we listen to is a result of molecules being pushed together and then spreading apart to form pressure waves in the air. There are chemical reactions involved in the eardrum when it detects these pressure waves. A signal is then sent to the brain where it's interpreted as sound. Even the emotions we feel when we listen to music are all results of chemical reactions. The very question itself, what is chemistry, is all made possible through a series of chemical reactions in the brain. Chemistry is quite literally the fabric of reality as we know it.
A common scientific definition for chemistry is the study of compositions, structure, properties, and reactions of matter. There is a lot in that statement, so let me break it down into smaller pieces. Okay, chemistry is a study of matter, so what is matter? Matter is mass that occupies space. Okay, I know what space is. What is mass? Chemists often use mass synonymous with weight. However, this term will not be acceptable to a physicist, and there is a difference between mass and weight. Mass is the amount, or pieces, of matter in an object. Mass does not change with the change in gravity. For example, the mass of something on the moon will have the same mass on Earth. Weight is a result of gravitational force applied to an object. Weight does change with the change in gravity. For example, the weight of something on the moon will not have the same weight on Earth. Let me show you an example of this with a case of beer. Okay, a good way to describe the difference between weight and mass is with a case of beer. Everybody knows what a case of beer is. It's got 24 cans in it. Okay, and each one of these cans represent a unit of mass. And we measured this mass on Earth, and it can, as I said, it was represented by the cans of beer. If we took that to the moon, and we had the same case of beer, with the same number of cans in it, I'm just going to put the same here. The gravity would not change the amount of mass. It would have the same amount of mass on Earth as it would the moon. So this would be equal. On the other hand, if we took that same case of beer it had 24 cans, and we weighed the case of beer on planet Earth, and each can represented some type of weight value. And we had the same number of cans in the case of beer, and we weighed it on the moon. Even if we had the same number of cans, the weight would not be the same. So this is not the same. So the takeaway of this is equals amount or pieces, and weight equals force of gravity. Mass and weight are not equal. Composition is the arrangement, type, and ratio of molecules. Looking at carbon dioxide, we can see that there's a specific arrangement where two oxygen atoms are on either side of a carbon atom. And this is the arrangement so long as a molecule is carbon dioxide. There will never be a carbon atom that is not in the middle, or oxygen atoms paired up on either side of the carbon atom. Here you can see that there's two oxygen atoms paired up on one side of the carbon atom. This will never ever happen with carbon dioxide. This is the correct arrangement. There's a clear type of atoms, carbon and oxygen. There's a clear ratio. There's two oxygen atoms to one carbon atom. And this will always be the composition of CO2 or carbon dioxide as long as a molecule is carbon dioxide. So the takeaway is composition is the arrangement, type, and ratio of atoms in a molecule. Properties are characteristics that distinguish one substance from another. This includes, but not limited to, density, boiling point, viscosity, reactivity, acidity, and flammability. There are different categories of properties such as physical and chemical. We will get into this more later. The takeaway is properties are characteristics that distinguish one substance from another. The chemical structure is how atoms are connected. Molecules can have the same number of atoms, but those same atoms can have a different connectivity to each other. Looking at these four molecules, you can clearly see that they're all different in structure. But if you look closer, they all have the same number and type of atoms. So each one of these molecules will have a formula of C4H10O or H10O. C4H10O. All of these molecules have that same formula. You can see there's 4 carbons, 10 hydrogens, and 1 oxygen. We'll get more into that later, but so there would be 4 carbons here, and these have, each one of these methyl groups have 3 hydrogens, so that would be 9, and then hydrogen here is 10, and then 1 oxygen right here. The only difference between all these molecules is the structure, or how they're connected. Like 1-butanol is very different from tert-butanol. But they all have the same type of atoms. They all have carbon, oxygen, and hydrogen. They all have 4 carbons, 1 oxygen, and 10 hydrogens if you count them up. The only difference is the connectivity between these atoms. So the takeaway is the chemical structure is how atoms are connected. A reaction is the interaction between two substances that produce a change in the product as a result of this interaction. I'm not going to go into this in great detail. I basically just wanted to go over the fundamentals. So bringing all this together and going back to our previous statement of what the scientific definition of chemistry is, the takeaway is chemistry is a study of compositions, structure, properties, and reactions of matter. What do chemists do, and how do I get there? There are many different types and levels of chemistry depending on his or her education. Generally speaking, chemists try to understand the tangible world around them by experimentally based results. To be a chemist, you should first get a degree in chemistry. Undergraduate degrees usually take 4 years after high school. The classes in this process would have individual areas such as general chemistry, organic, physical, and analytical. More classes could be taken. Employees at an undergraduate level are typically limited to technical work and bench work. Graduate degrees include a master's and PhD. A master's degree is usually 5 to 7 years. In the graduate degree process, additional advanced classes would be taken to go into more chemical detail. At a master's level and higher, students begin to see how individual branches of chemistry work together in a congruent manner. At a graduate degree level, chemists are more involved in projects. Research is drawn from knowledge that is gained throughout school in the direction of the mentor. Chemists try to understand the tangible world. The level of schooling and type of education usually determine the work field, pay scale, authority, and responsibility level. The questions that you should really ask yourself is, do you have what it takes, and how bad do you want it? I can't answer these questions for you. Only you can. Chemistry is considered to be essential science and it overlaps with many different fields of study, such as mathematics, physics, biology, and computer science. Two growing areas that overlap with chemistry are biology and computer science. These areas, previously known as two different fields, have now merged into one focused area of expertise.
Okay, so what are some chemical industries? The food industry. Food chemists are involved in processing, production, packaging, and storage. Food chemists also work with additives and preservatives. Pharmaceutical industry. Chemists play a key role in drug discovery, drug development, and delivery systems to treat illnesses like cancer and infectious disease. Petroleum and alternative fuels. Chemists are constantly used to find or improve alternative and mainstream energy production, cheaper, faster, and more efficient. Specialized materials. Chemists also play a key role in specialized materials, such as biodegradable plastics, heat-resistant metals, and bulletproof clothing. Branches of chemistry. Organic chemistry can be found in the pharmaceutical and petroleum industry. Inorganic chemistry would be a good fit for nuclear power and specialized materials. Analytical chemistry would work effectively with water quality and drug standard developments with pharmaceutical industries. Physical and computational chemistry are commonly in research and development departments. Many breakthroughs have happened in pharmaceutical industries with the advancement of computational chemistry. Biochemistry works close with the medical and pharmaceutical field. This is no means a definitive link between chemical branches and industry, but it's a good congruent match. The purpose of science is to find the truth, or the closest we can get to it. Mathematics is the purest form of science. 1 + 1 = 2. We know this to be true. There can be some ambiguity with chemistry. In fact, scientists will never know the absolute 100% truth about chemistry, but we can be very close. This can be very aggravating for some people, especially those who are more comfortable with the mathematics end of science. To clarify and close the gap between what is actually happening and what we understand, scientists use what is called the scientific method. We'll have a closer look at this soon.